two identical sphere of radius r made of the same material are kept at a distance d apart. The gravitational attraction between them is proportional to. We can calculate what is gravitational attraction. G m1 m2 upon d square. So it will depend upon d raised to the power minus 2, direct formula. Three equal masses of 1 kg each are placed at the vertices of an equilateral triangle and a mass 2 kg is placed at the centroid. What is the distance of root 2 meter from each of the vertices of the triangle? The force is Newton acting on the mass of 2 kg is. We will check. We have one equilateral triangle ABC. Centroid O. It is centroid O, which is at a distance of root 2 from each. Root 2 from this, root 2 from this, root 2 from this. These two, it will attract in this direction, it will attract in this direction. Suppose I am denoting it by F1, it is by F2. Since distance is same and M1, M2 are also same, so F1 should be equal to F2. Gravitational attraction of B and C, it should be same. I am saying this force A will attract towards A. It is, I am saying, F3. Magnitude wise F1, F2 and F3 are same. Suppose I am saying them F. So what is the resultant of F1 and F2? It will act between them. Because both are equal, just bisecting this, just in opposite direction of F3. What is R? R is under root F1 square plus F2 square root P square plus Q square plus 2PQ cos alpha, 2F1 F2. This angle is 120, so I am writing cos 120 degree. Cos 120 is minus 1 by 2. So what we are getting? F square plus F square plus 2F square into minus 1 by 2. Cancel 2 with 2. This minus F square will cancel this plus F square. So we are getting F. Since R is in just opposite direction of F3 and is equal in magnitude, so R will cancel F3. So net force is 0, so we are going with D. We are going with D. Suppose the gravitational force varies inversely as the nth power of distance. Then the time period of a planet circling in orbit of radius r around the sun. Gravitational attraction now it will become G, mass of sun, m1, mass of planet, m2 upon. In place of r square, we will take r raised to the power n now. They are saying inversely as the nth power of the distance. Now this gravitational force will provide planet centripetal force. Cancel m with m. What we want to calculate? Time period of planet. Its relation with r. So now GMS upon r raised to the power n minus 1. Cancel 1 r. V square. What is V square? V is omega into r. So omega square into r square. Take this r on this side. So omega square is equals to G, mass of sun, r square in this way, so it will become r raised to the power n plus 1. But omega is 2 pi by t. Take square root on both sides. This implies omega is equals to root gms. Upon root of this means r raised to the power n plus 1 by 2. But omega is 2 pi by t. So root gms upon r raised to the power n plus 1 by 2. Take this r on that side, t on that side. So t is proportional to r raised to the power n plus 1 by 2. So we are going with option C. Remaining were constant. A mass m is divided into two parts m and m minus m, which are separated by a distance, the ratio of m upon m, which maximize the gravitational force between the parts is C. It is m is divided into two parts. It is m. And now it is m minus m. It is distance between them. It is constant. So ratio of m upon m, so that gravitational force between the parts is maximized. What is gravitational force? G, m1, m2 upon d square. To maximize this, product should be maximum, and we know that if we are dividing a number in two parts, product will be maximum when numbers are same. See, I am dividing 4 in two parts, 1, 3, 5 into, I am dividing 6 into two parts. It is a problem of maxima minima, but you are a bio student, so I am explaining in this way. Suppose I have a number 6. I want to divide it in two parts. Product should be maximum. Possibilities are 1, 5, 2, 4 and 3, 3. In this case, product will be 5. In this case, product will be 8. In this case, product will be 9. So product will be maximum when both parts are equal. It means when m minus m is equals to m, then you will get this product maximum. Means when m is equals to 2m. Means when m upon m is equals to 1 by 2. So we are going with option C. 35. Three identical bodies of mass m are located at the vertices of an equilateral triangle of side L. They revolve under the effect of mutual gravitational force in a circular orbit, circumscribing the triangle while preserving equilateral triangle. Their orbital velocity is. So what we have to do, first we will calculate the total force they will get. The total force will provide them the centripetal force. What we are saying? We are keeping the body, two bodies, located at the vertices of an equilateral triangle of mass m. It is mass m. It is mass m. It is also mass m. And this distance is L. We know that the circumcenter, orthocenter, all types of center in equilateral triangle is at same point. So I am going with centroid. It is the radius of the circle. If particle is circumscribing the triangle, the radius of circle should be this. And what is it? It is the 2/3 of the median. What is the length of median? It is L by 2. It is L. So this should be equal to total length of median. So then we can calculate R. So total length of median is equals to under root L square minus L square by 4, L root 3 by 2. It's 1/3. Its 2/3 portion is R. So R should be, radius should be 2/3 of this L root 3 by 2. Means radius of circle is L by root 3. Which force will provide this centripetal force? Gravitational attraction. Now two forces are there. One is acting in this direction. It is, I am denoting it by F1. And it is F2. Both are equal. And angle between them is 60 degree. So I am multiplying 2. So net force which is providing centripetal force is 2 into 1 force G M1 M2 by L square. So we have to take the resultant of these two forces, and angle between these two is 60 degrees. So first we will go for resultant force under root P square. Suppose F1 is equals to F2 is equals to F. So what we are getting? P square plus Q square plus 2PQ cos alpha 2 F square cos 60 1 by 2. So what is resultant force? F root 3. So resultant force is F root 3. And what is F? G M1 M2 upon R square. So F root 3 is this. It will provide centripetal force which should be M V square by R. R is L by root 3. So cancel root 3 with root 3. 1L with 1L. 1M with 1M. So what we are getting? Orbital speed root Gm by L. Root Gm by L. So going with A option. Next, a uniform ring of mass m and radius r. It is a uniform ring. A place directly above a uniform sphere of mass 8m, same radius r. The center of the ring is at a distance of root 3r from the center of the sphere. The gravitational attraction between the sphere and the ring is, we know that intensity at the ring at d distance, intensity of gravitational field we can calculate by the formula GMD, GMX. We studied in this electricity. So what is it? D square plus R square raised to the power 3 by 2. It is the formula for intensity of gravitational field at a distance d from the center of ring. Intensity means force experienced by unit mass. So if mass of ring is m and its radius is r, so from this distance it will put this electric field, but we are putting 8m at this, so it will experience a force of this. In this case d is equals to root 3r. So d square means 3r square, so it will become 4r square. So what we will get? First we calculated I, it is I. So total force means 8m. For force we will multiply by 8m. First we calculate intensity at d distance. Now we are putting the values G, M, D. 8m will experience 8m times force. D is root 3r. Square means 3r square and 4r square. 4r square's root. It is 2r and its cube. It will become 8r cube. It will become 8r cube. So what we are going to get now? GMD, and value of D in numerator we again putting root 3R, root 3R. So cancel 1 R, we get 2. Cancel 8 with 8. So what we are getting? GM square root 3 upon R square. So we are going with option D. 37th, two solid spheres, planets of equal radii are having mass 4m and 9m, have their centers separated by a distance 6r. A projectile of mass m is sent from one planet to another. What is the distance r of the point from the lighter planet where the gravitational force on the projectile is 0? It means at that point, force due to both should be equal. See, one planet is this, one planet is this. It will attract satellite towards it and it will attract towards it. Its mass is 4m and its mass is 9m. And distance between their centers is 6r. Suppose from one at x, from the lighter suppose at r distance, gravitational field is 0, gravitational force is 0. It means from this distance should be 6r minus r. What force it will put on this? It will put a force G m1 m2 upon r square. What force it will put? G m1 m2 by 6r minus r whole square. Cancel G m, take square root. So 6r minus r, take it on this side, 6r minus r, and square root of 4 is 2, square root of 9 is 3, and square root of r square is r. So it means 12r is equals to, take this 2r on that side, 5r. So r we get 2.4r. So we are going with option D. 38. Four particles each of mass m and equidistant from each other move along a circle of radius r under the action of their mutual gravitational attraction. The speed of each particle is again same type of problem. Four particles equidistant from each other means they should be on one square. Move along a circle of radius r under the influence, the mutual attraction, same type of problem again we are getting. So this is, they are equidistant from each other and mass is m. If this distance is x, it should be x, it should be x. Four masses are here. It will attract in this direction, it will attract in this direction. We are taking one this, it will attract in this direction. The speed of each particle is, so what is the total force acting on this? First we will calculate that. Due to this mass, force F1, and due to this mass, force F2, they should be equal. F1 is equals to F2, say is equals to F, and they are acting at 90 degree, and this is F3. First we will calculate the resultant of F1 and F2. It will be in the direction of this only. So what is R? R means under root F square plus F square, because angle between F1 and F2 is 90 and cos 90 is 0. So we are getting F root 2. What we are getting? F root 2. Next, they are moving in a radius of r. They are saying they are moving in a radius of r. So we will calculate that also. because r will become now the radius, and in this we can calculate x because r is diagonal, so r should be equal to x root 2. So this whole particle will put a force F3, so F3 should be equal to m1 m2 g m1 m2 divided by r square. And what is F? F is equal to g m1 m2 upon x square. And what is x? X is r by root 2. So we can write it g m square into this root 2 is also there. We are writing this root 2. So resultant we are calculating g m square into root 2 x. X square means r square by 2, taking 2 in numerator. So it is resultant. So final force is r plus F3, which is g m square by r square. Take this common, 1 plus 2 root 2. It will provide m v square by r. Cancel this r with this r, and 1 m, cancel 1 m. So what we are getting v? We are getting v is equals to under root g m by r into 1 plus 2 root 2. So we are going with option D. Next, 3 particles each of mass m are placed at vertices. The magnitude of gravitational force on any one due to other 2. See, it will attract in this direction, it will attract in this direction. Both forces are same and angle between the forces is 60 degree. If it is F, it should be F. So resultant should be under root F square plus F square plus 2F square cos 60. Cancel 2 with 2. So resultant is equal to root 3 times of one force, and one force is g m1 m2 upon r square. So what we are getting? G m square upon r square root 3. So going with B. Next, a point mass m is placed inside a spherical shell. The gravitational force by the shell inside the gravitational shell, gravitational field is 0. So we are going with option C. 41st, the acceleration due to gravity g at distance r from the center of earth. I explain you in theory sheet कि inside the earth g is directly proportional to r. If you are moving away from the center, it will increase directly proportional. We explained in the theory of this. Now 42nd problem. The height of the point vertically above the earth's surface at which the acceleration due to gravity becomes 1% of its value at the surface is. Suppose the height is h. On surface the value of g is gm upon r square. If we are going at height h, g dash is gm upon r plus h whole square. But what they are saying, g dash is 1% of its value, means g into 1 upon 100, it's 1%. So they are giving us g dash upon g is equals to 1 upon 100. But g dash upon g from here we can see it is r square upon r plus h whole square. It is 1 upon 100. Taking square root we are getting r upon r plus h is equals to 1 by 10. So 10r is equals to r plus h. So h should be equal to 9r. So we are going with option B. Next, the depth at which the value of acceleration due to gravity becomes 1 upon 9n times the value at the surface is, we know that when we are going in depth, what they are saying, g dash should become g by 9, but formula for g dash is g into 1 minus h upon r. They are saying it should be g by n, cancel g with g. What we are getting, 1 minus h upon r is equals to 1 by n. So h upon r is equals to 1 minus 1 by n, means n minus 1 by n. So what should be h? It should be r into n minus 1 by n. So we are going with option C. 44. Imagine a new planet having the same density at that of Earth but 3 times bigger than the size in the Earth. If the acceleration due to gravity is same, the g dash, imagine a new planet having the same density, size 3 times bigger. If the acceleration due to gravity on Earth is g, what should be on that planet? We know that on g, Earth's surface, it is gm upon r square. What they are saying for that planet? But in terms of density, it should be 4 upon 3 pi r cube into density re square, cancel 2r. So it is for Earth. For that planet, g same, 4 upon 3 pi same, size 3 times, so we are putting 3 re, density same. So it means it should be 3 times the value of Earth. So g dash should be equal to 3 times g. So we are going with A. Mass remaining constant, the radius of Earth shrinks by 1%. The acceleration due to gravity on Earth's surface would, see, what is the formula for g? It is gm upon r square. What is the new value of g? Mass remaining constant, radius shrink by 1%. So new radius is r minus 1% means r into 1 upon 100. So it is 99 r by 100. So in place of radius we have to write 99 r by 100. Since we are decreasing the denominator, so it should be increased, means either A or B. By what percent we have to calculate? So by what percent it is increasing means g dash minus g by g into 100. We want to calculate this figure. Means we want to calculate g dash by g minus 1 into 100. So what is g dash by g? Divide g dash by g, gm by r square will be cancelled out. What we will get? Only 100 by 99 its square minus 1 into 100. We can write 100, 99 plus 1. So we can write this in split form. 100 means 99 plus 1. So we can write it 99 by 99 1 plus 1 upon 99 g dash by g. We want to calculate g dash by g. So square minus 1 into 100. Using binomial, we are writing 1 plus 2 by 99 minus 1 multiplied by 100. Minus 1 is cancelled out with this. So nearly we are getting 2%. So increase by 2%. So we are going with A. So in this way, It is the completion of your gravity and gravitation. Thank you.